Good morning, students. I'm a chemistry teacher. I'm going to take you through chemistry. Today we are going to do a certain topic in Form 4 known as nitrogen and its compound. This is a very high-tested topic in the KCSE level. As you can see, this is a book known as KCSE Made Familiar Chemistry. It contains both paper 1 and 2 for the first paper. This is the latest one, 2025 edition. So I'm going to guide you on how to tackle this question. As today you can see, I have drawn a clear picture of an example. We are going to tackle it. Please pay a lot of attention for you to understand. We will begin with the first question. The first question says, study the following and answer the following question. Name the element M. Now, as we can see, our element M is here. So we can see that element M is reacted with nitrogen. As we know, nitrogen are reacting us when element M and nitrogen is reacted, it forms ammonia. And we know very well that hydrogen is the only element which, when reacted with nitrogen, forms ammonia. So we are going to write an chemical equation to show the formation of ammonia. Now we'll have our element M as hydrogen gas added to nitrogen gas, which forms ammonia gas. This one, it is mixed in a ratio of 1:3, which is not very important to know at this time. So we are going to our second question, and we have come to notice that our element M is hydrogen gas. Okay. Our second question says that why is it necessary to use excess air in step 2? As we can see, we were done with step 1, which is reacting of nitrogen and hydrogen. So in step 2, we can see that ammonia is reacted to form a colorless gas cube. Now, we were told that air, which is oxygen, was added in excess at a catalyst of platinum rhodium. So, oxygen which was added in excess was to ensure conversion of ammonia to nitrogen 2 oxide, which is further converted to nitrogen 4 oxide. I think everyone has understood, or I am going to repeat again. Now, excess air is used to ensure total conversion of ammonia gas to nitrogen 2 oxide, which is further on converted to nitrogen 4 oxide. As we know very well, oxygen is an oxidizing agent, so that's why it will convert. Now, I was repeating the Y is oxygen used in excess in step 2. I said that this is because it needs to convert all ammonia gas in this chamber to form nitrogen 2 oxide, which is further on converted or oxidized by oxygen to form nitrogen 4 oxide. We'll go to the next question. The next question, they are saying identify gas Q. Gas Q. We can see gas Q came from ammonia. Which ammonia? Ammonia was the same ammonia which was used as a catalyst of platinum rhodium and air. And we said earlier it was converted to form nitrogen 2 oxide, which means this gas here, it is nitrogen 2 oxide, which is a colorless gas. Okay, we'll go all the way to the next question. write an equation for the reaction in step 5. In step 5, you can see our step 5 is here, where we have nitric acid coming from nitrogen 4 oxide. So, you can see this arrow comes from ammonia, which means we reacted ammonia and nitric 5 acid, as I'm going to write an equation for you. We had ammonia gas, which is written like this, plus nitric acid, which forms ammonium nitrate, which is an aqueous. This is, as we know, nitric acid is also an aqueous. We will check if the equation is balanced. As you can see, the number of nitrogen we have in this one, they are 2. The other side, they are also 2. The number of nitrogen, they are 3 plus 1, 4. The other side, they are 4. And the number of oxygen, you can see they are 3. And the other side, they are 3, which means our chemical equation is already balanced. So, we will move to our question. Give one use of ammonium nitrate. Ammonium nitrate is a product which was formed from ammonia and nitric acid. One of the uses is that ammonium nitrate is used in manufacture of fertilizer. Manufacture of fertilizer. Another one you can say or write it is that it is used in laundry. We are going to answer the last question. They are asking, state and explain the observation that would be made if a sample of sulfur is heated with concentrated sulfuric acid. Now, if a sample of sulfur is heated with a concentrated nitric 5 acid, we know very well that concentrated sulfuric acid is an oxidizing agent. As you know, concentrated nitric 5 acid is an oxidizing agent. So, it will oxidize sulfur to form sulfuric 6 acid, which forms brown fumes. So, you'll say like this as you will be writing your answer. Brown fumes will be formed. You can see, you can write formation of brown fumes. This is because, as I said earlier, that nitric 5 acid is used as an oxidizing agent, which means it oxidizes sulfur to form sulfuric 6 acid, and it itself as nitric 5 acid is reduced to form carbon 4 oxide. I will repeat again. There will be formation of brown fumes. This is due to the oxidizing of sulfur by concentrated nitric acid, and the nitric acid itself will be reduced to form nitrogen 4 oxide. That is all about lesson today. Don't forget to subscribe in our YouTube channel. Thank you.